Hello, this video is about enthalpy change and Hess cycles, and it's an OCR F322 past paper from January 2012. So the question sets up by stating that enthalpy changes can be determined directly or indirectly. The indirectly is the nod to the fact we're going to get a Hess cycle question later, and the directly is the experimental method. There's always going to be basically two steps to start the direct ones. One, where you're going to find the energy transfer using Q equals mc delta T, and in the second part you will have to find the number of moles involved. So we're given a reaction, it's magnesium and hydrochloric acid, and the student is going to determine the enthalpy change for this reaction. It tells you how much magnesium is reacting, and it gives you a volume and a concentration of hydrochloric acid. Telling you that that's in excess means you don't need to worry about doing M equals CV here, almost like a red herring. And it gives you a temperature change. Well, we're going to want to quickly calculate delta T, so looking at that, it's 12.8 degrees Celsius, and we have to calculate the energy released. Careful, read all the parts in kilojoules during this reaction. Tells you specific heat capacity, well that's the C, and it tells you the density is 1 gram per centimetre cubed, which is really useful because we have 50 centimetres cubed, which means it has a mass of 50. So the first thing we could do, remember for that mass, it's the mass of what's being heated up. The most common mistake would be where people use the mass of a solid that's reacting. It has to be the mass of the water or the surroundings or the solution, and very nicely this solution has a density of 1. So 50 grams, C is given as 4.18, delta T we've got up there at 12.8, so putting all that together gives me 2675.2 joules. Now you get 1 mark for just putting these in. Looking here, every single one of these is to 3 significant figures. So I'm going to convert it to 3 significant figures. You don't have to at this point, but you're going to end up writing, because you're going to divide by 1,000, you're going to write 2.6752, so it just makes sense. So 2.68 kilojoules, 2 marks there. Right, calculate the amount of moles of magnesium used. Well, we have our mass, so 0.486 divided by the mass of 1 mole of magnesium, which is 24.3, and all of that pops out quite nicely at 0.02 moles. So now we need to get to the enthalpy change. So here we're going to take the number of moles that we've just got, and we know that that is the energy released for this many moles. But we now need to find out how much energy is coming from that, the 1 mole, so you take the 2.68, or whatever it happens to be for any given question, and you divide it by the original number of moles, and if we do all of that, we are going to get, oh hang on, 3 significant figures, great, 134. And I can't speak, and that right there is where most people go, hey, I've got a number, I'm happy, look at me, I got three significant figures, and they move on. There's 3 marks. There's an extra thing you really need to be aware of for this. Go and double check your reaction. The solution heats up. It's exothermic. We know that an exothermic reaction needs to be a negative value here, so don't forget to double check for that. Okay, next part of the question, part B. Definition. To make this a little bit easier for the video, I've put in some of the key bits already. You always start off your definition with enthalpy change when, and we were asked about the enthalpy change of formation. Now there are 3 marks, so we're going to have to make 3 points worth of evidence and information, and it says you should state the standard conditions. So there's going to be 1 mark for what the standard conditions are, and 2 marks for what's going on. The first thing, there's always a mark for how much of what it is, and the second is always for what's going on. So it's the enthalpy change when 1 mole, and it's of a compound. So So that's the first bit you want to get in. For formation, it's when 1 mole of a compound is formed. Clue is pretty much in the name. And the crucial bit from its elements. And you're going to want those elements to be in their standard state. So that's your second mark. And now for the conditions. 298 kelvins, 100 kilopascals. If a solution was used anywhere, you would put it at 1 mole per decimeter cubed, but there are no solutions here. Right. Lastly, there is an indirect calculation using a Hess cycle. However, unlike the typical question where you're given one reaction and you have to make a triangle, here we're given a cycle, but there's more than 3 steps. So if you see something like this in the exam, the first thing to do is just to take a deep breath and calm down. The principles are going to be just the same. We have ultimately everything starting at the top left, and then the arrows all converge here. So I'm going to call this step A1, I'm going to call this step A2. And I know, therefore, using Hess's law, that A1 and A2 are going to be equal to these steps here. So let's call this, say, B1, B2, and B3. And it doesn't matter how many steps there are, or to be honest, what you call them. Just the things going round that way are the same as the things going round the other way. You're given 4 values and 4 equations, and there are 4 boxes here. So there's a good bet that they're going to match up. So it's simply a case of looking carefully at what's changing. So starting at the top left, carbon and oxygen don't change. The calcium and the hydrochloric acid do change to calcium chloride and hydrogen. So it's not that, it's not that, it's not that. Oh, it's the bottom one there. So we're going to put in -168. Tick that one off. Now, calcium chloride stays the same. Carbon stays the same, but it's hydrogen reacting with some oxygen to make H2O. Great, that's the second one down. -285. And then here, calcium chloride isn't changing, water isn't changing, but carbon and oxygen come together to form carbon dioxide. So we're going to put in -393. And in fact, we can put all of these down here. -168 plus -285 plus -393, and we know that all of those added together is -846. Right, what about the other root? Well, this one is going to be our unknown, and there's only one that I haven't used. Rather than just plugging -54 in, let's make sure it's correct, because that is going to let us confirm everything we've done already. So we've got calcium carbonate and hydrochloric acid forming calcium chloride, water and carbon dioxide. Hey, lo and behold, that's -54. So this question, they gave 2 marks if you got all 4 of these correct, 1 mark if you got 2 of them, or 3 of them correct. I'm not quite sure how you'd get 3 of them correct and then not get 4, but hey. So therefore over here we know that A1 plus -54 equals all of those. I'm going to keep it in place just a little bit longer. I would always add up the things on one side so that you don't fall foul of double negatives or subtracting when you should have added. So this A1 plus -54 equals -846. So you're going to add 54 to both sides. So A1 or delta H equals -846 plus 54, which comes out at -792.